There are so many places and things to explore in the universe, from distant exoplanets to faraway galaxies that might host intelligent life, to massive black holes to bright stars. However, there is a problem with space exploration: distance. Everywhere you want to go in deep space is far. For example, Elon Musk wants to put humans on Mars permanently, while NASA wants to send astronauts there. However, any traveler going to Mars has to endure a grueling trip through harsh space that lasts not less than 5 months, even with the most powerful rocket in history. If only we could find a faster way to travel through space. Also, the next star to us is about 4.5 light-years away, making it impossible to visit with the current space technologies. However, an accidental discovery promises to fix that problem by enabling faster than the speed of light travel. What is the discovery? How does it affect space travel? And how does it affect you personally? Join us as we explore how NASA scientists accidentally discover the world's first warp bubble. Warp travel is not strange to fans of the Star Trek franchise. The warp drive is a charming, futuristic technology from the Star Trek universe, which since its first episode in 1966 includes 10 television series and 13 feature films. In these series and movies, characters explore the universe using powerful and fast spaceships, traveling from planet to planet and communicating with a crew of aliens. The torsion engine is the center of attraction because without it, the story would be implausible. The universe is strange, unimaginable, and insanely large, and even if you want to visit the next star, the immense cosmic distances create an almost impossible barrier. Let's take a look at the next star, Proxima Centauri, 4.5 light-years away. This distance means it takes 4.5 years to reach the star if you could manage to attain the speed of light. Light flies at full cosmic speed and acts as a sort of universal speed cap, so any other method takes longer. In fact, if you decide to use the fastest space probe ever built, the long journey through the interstellar void would take nearly 8,000 years. So it makes sense to stay put to Earth and its immediate environment. Of course, the Star Trek crew didn't stay close to the Earth because they found a solution. This solution makes long-distance travel possible by shortening the distance. The torsion engine using warp drive tech achieves this by juggling space and time, making for great entertainment. Warp drive was destined to remain imaginary until a scientist suddenly realized that such an engine was really possible at the end of the last century. The physicist was Miguel Alcubierre, and he came up with a theory that rocked the scientific community globally. In 1994, Alcubierre watched an episode of Next Generation while doing his PhD research on Einstein's general theory of relativity, where heavy masses can curve space and time. And so Alcubierre picked up a scrap of paper, did the calculations, and laid the foundation for an article that appeared in the Science magazine later that year. In his paper, Alcubierre describes how you can compress space and time in front of a spacecraft and stretch it back behind the ship so that you have to travel a much smaller distance to the desired destination, safely trapped in what he calls a torsion bubble. In visualization, the concept was compared to a surfer riding a wave, and a metaphor often used to describe how a ship could travel the stars. There is, however, a problem with Alcubierre's warp bubble. You see, the warp engine is tough to build in reality. You can't just curve space forcefully with normal mass. To do so, you need exotic matter, which has negative gravity. Dozens of warp engine publications would follow in the following decades, but they all remained theoretical exercises and thought experiments that manipulated the formulations of the theory of relativity in search of new insights. The need for the foreign matter remained. That was until Eric Lentz, a physicist at the Pacific Northwest National Laboratory in the US, stepped in. He watched Star Trek as a kid, however, he has not been able to forget about the warp drive and has been thinking of how to bring the special machine to life. Lentz first read Alcubierre's professional article when he was a teenager, and while he found it fascinating, he didn't understand much about it at the time, but he continued to read warp drive publications long after he started working as a physicist. However, when he had some time to spare during the COVID lockdown months, he returned to his old interests. That was when he realized that everyone had overlooked something. In his article, Alcubierre investigated the simplest possible solution to the formulations of the theory of relativity. This solution resulted in the Alcubierre engine, a warp bubble powered by a massive amount of negative gravity. Lentz decided to try some of the more unusual mathematics and realized he could also solve formulas with it. In the torsion bubble obtained by lens, the mass was in the places where the curvature was greatest, but much more importantly, you can make his bubble with ordinary, everyday things. You didn't need an ounce of Stranger Things. Lens was surprised that no one had tried this before. Although the Lens engine was already more practical than the Alcubierre engine, you still needed a lot of mass for it. But it is still because you need mass 1,000 times smaller than the Sun. That's still a massive amount of kilos, but it is more manageable. It looked like warp bubbles could be put to rest as a concept that could never happen in real life. However, a completely chance discovery is fueling interest in warp bubbles again and could prove to be a breakthrough. A research project funded by the Defense Advanced Research Projects Agency (DARPA) and NASA's Johnson Space Center may have accidentally discovered how to build a warp drive engine. Harold Sonny White, a NASA researcher at the Eagle Works Laboratory in Houston, Texas, published a research paper with his team in July about the possible structure of the energy density present in a Casimir cavity. According to the report, the Eagle Works team came across a micro-nanoscale system that predicts negative energy density distribution that closely matches requirements for the Alcubierre metric. In other words, White and his colleagues accidentally created a microscopic experiment while researching how energy distributes around wavelengths, a theory developed by Dutch physicist Hendrik Casimir. The experiment resulted in enough theoretical energy to achieve warp speed, concept theorized by Alcubierre. In an interview, White explained that detailed numerical analysis of the team's custom Casimir cavities helped them identify a real and manufacturable nanomicrostructure that is predicted to generate a negative vacuum energy density such that it would manifest a real nanoscale warp bubble, not an analog. Still, the real thing, meaning a warp bubble structure, will manifest under these specific conditions. White was also aware that Alcubierre's proposed mathematically valid solution to the warp drive that can traverse the cosmos above the speed of light without violating currently accepted laws of physics. He was also aware of how the solution had been derided for its use of theoretical materials and massive amounts of energy that appeared virtually impossible to engineer in any practical way. However, White, a then NASA-employed warp drive specialist and the founder of the highly respected Eagle Works Laboratory, reworked Alcubierre's original metric and put it into canonical form. This change in design dramatically reduced the original concept's exotic materials and energy requirements. This reworked concept provided researchers and science fiction fans alike at least a glimmer of hope that a real-world warp drive may one day become a reality. It also resulted in the informal renaming of the original theoretical design, a concept now more commonly referred to as the Alcubierre-White warp drive. Back when White began his latest DARPA-funded research into custom Casimir cavities, a unique microscale structure with all types of promising applications, he definitely did not expect to stumble upon this potentially historic discovery, particularly one supporting a theoretical concept that he has often been outspoken about. Casimir cavities and the tantalizing quantum-scale forces are in no way related to warp drive theory or mechanics, or at least they never had been before. But, says White, it is work that he and his LSI team are passionate about and something DARPA believes has a number of possible applications. So whether by pure coincidence or some sort of personal destiny, it appears that one of the handful of engineers on the planet who would immediately know what it was he was looking at when conducting his Casimir cavity research was in the exact right place at the exact right time to notice a striking similarity to his warp drive passion project and his current research, an observation that may have otherwise gone unseen. When White and his team published their findings, it became the first paper in the peer-reviewed literature that proposes a realizable nanostructure that is predicted to manifest a real warp bubble. This fortuitous finding not only confirms the predicted toroidal structure and negative energy aspects of a warp bubble, but also resulted in potential pathways White and other researchers can follow when trying to design and one day actually construct a real-world warp-capable spacecraft. According to White, this is a potential structure we can propose to the community that one could build that will generate a negative vacuum energy density distribution that is very similar to what's required for an Alcubierre spacewalk. To further evaluate his groundbreaking results and move the research forward, White and his team have come up with a proposed design for a testable nanoscale warp drive craft. The original experiment White's team was working on consisted of a toy model consisting of a 1-micron diameter sphere centrally located in a 4-micron diameter cylinder. This was analyzed to show a 3-dimensional Casimir energy density that correlates well with the Alcubierre warp metric requirements. White therefore believes that chip-scale experiments might be explored to attempt to measure tiny signatures illustrative of the presence of the conjectured phenomenon, a real, albeit humble, warp bubble, the holy grail of Star Trek. He proposes that the community use this potential structure to generate a negative vacuum energy density distribution similar to what's required for an Alcubierre space warp. White and his team have neither built nor tested the proposed nanoscale warp craft design. However, he noted if the LSI team were to undertake that at some point, they would probably use a NanoScribe GT 3D printer that prints at the nanometer scale. Basically, they have the means to do it, they just need the opportunity. Sadly for Star Trek fans, White says there is no plan to do this currently because they are laser-focused on the custom Casimir cavities. However, even though White and his team cannot currently build the proposed nanoscale warp craft, they have outlined a second testable experiment that involves stringing a number of these Casimir-created warp bubbles in a chain-like configuration. This design would allow researchers to better understand the physics of the warp bubble structure already created and how a craft may one day traverse actual space inside such a warp bubble. Don't be surprised by White's reluctance to branch into building nanoscale warp drive models. DARPA is paying the LSI Eagleworks lab to explore Casimir cavities and not the accidental discovery of a warp bubble, regardless of its potentially staggering implications or the excitement surrounding it. However, White believes it's a matter of time before his mini-warp craft is designed and tested, whether by him or another researcher. White cautioned that this doesn't mean we are near building a fully functioning warp drive, as much more science needs to be done. However, there is at least a glimmer of hope that humanity one day could be zipping all over the cosmos in a Star Trek-inspired warp bubble. Let's hear what you think of the warp drive in the comments section below.